Unit 2 Chemistry, Chapter 18, Part 2. We're going to look at a special technique called gravimetric analysis. So we've got a mixture which is in solution, and we want to know the concentration of one soluble ion in there. We're going to do that by precipitating it out and then weighing the precipitate and finding the amount in molar precipitate, and then we can backtrack using our mass stoichiometry to find the amount in mole of the ion that we had. So to do this, we've got to make sure we make a precipitate with a known formula, that it's got low solubility, so it will actually precipitate out. We're going to have to dry it, so it's got to be stable when we heat it to get rid of all the water. And we've also got to make sure that it doesn't form compounds with other ions present, because we don't want to have a mixed precipitate, which is lots and lots of different things, because remember that stoichiometry only works with pure substances. Okay. So things that we might use, for instance, if you want to know the amount of chlorine, you could precipitate it out as silver chloride. If you want to know the amount of bromine, you could precipitate it out as silver bromide. Okay, there's a whole range of different things and what precipitates they could have. You know your solubility rules. Yeah, so you should be able to use that to work out what precipitate we could form. Okay, so remember sodium, nitrate, ammonium, potassium, always soluble. Carbonate, hydroxide, phosphate and sulfur are soluble unless they're with one of these. And bromide, iodide, chloride and sulfate are soluble unless we put them with silver or mercury. So, for instance, if we've got some seawater, and now our salt actually is sodium chloride, and we want to know the concentration of the sodium chloride in parts per million by gravimetric analysis. Now sodium we can't precipitate out because it's always soluble, but the chloride we can, and we only need to precipitate out one of them. Okay, we know that silver chloride is insoluble, so if we add silver nitrate, we're going to precipitate that out. And nitrate, silver nitrate is a good one to use because the nitrate isn't going to precipitate with anything else, so we're less likely to get a mixed precipitate. So our ionic equation is we're going to take the silver ions that we're adding, they're going to react with the chloride ions that we want to find out about, and we're going to make silver chloride as a solid. So here's our balanced equation. Okay, we have a 100 ml sample of the seawater, and we add more than enough of those silver ions. We extract our precipitate, we dry it, and we find its mass is 0.0324 grams. So from there, we've got this mass, we divide it by the molar mass of the silver chloride, because the precipitate is silver chloride. And we use that to find the amount in mole of it. We then can use the amount in mole of the silver chloride to find the amount in mole of the sodium chloride. So it's a 1-to-1 ratio, silver chloride to chloride ions. So it's going to be the same. Okay. If we then wanted to find the mass of the sodium chloride, we can then multiply by the molar mass of the sodium chloride. Okay. I know it was just the chloride ions that we reacted with, but remember that the whole thing is sodium chloride. Okay. So we've got 0.0131 grams. Okay. Which is equivalent to 13.1 milligrams. Okay, we want to find it in parts per million. Parts per million, remember, is the same as milligrams per litre. So I'm going to convert that volume into litres and do 13.1 divided by 0.1 litres, which gives you 131 milligrams per litre, or 131 parts per million. Now, in this one, you were told that we were added an excess of silver ions. In some cases we don't. Some cases they don't tell you what's in excess, they just tell you the amount of two reactants, and you've got to figure out which one is limiting. The limiting one is the one that's going to run out first, so that one's actually going to determine how much of your products you can make. So once you've figured out which one's limiting, that's the only one you use to do your stoichiometry. So say we had 2 grams of hydrogen and 8 grams of oxygen. We want to know how much water is going to be produced. So we start by doing our balanced equation, because that's what we always start with. We then find the amount in mole of each of them. The amount in mole of hydrogen is greater. Okay? But we actually need more hydrogen here. Okay, so then we look at it and we go, okay, I need 2 moles of hydrogen to react with every mole of oxygen. So for 1 mole of hydrogen, that would react with 0.5 moles of oxygen. Oh, but look at it, I don't have 0.5 moles of oxygen. I've got less, so therefore oxygen is limiting. A simple trick to use, actually, is to take the amount in mole of each substance and divide it by the coefficient in the equation. Okay, so you divide this by 2, divide that by 1, so you're going to get 0.5 and 0.25. Whichever number is smaller once you've done that is your limiting reagent, and the other one is in excess. So now we know this is our limiting reagent, we're going to use this one and that stoichiometric ratio, so 1 to 2, to find the amount in mole of water that's made. Okay, so 0.25 moles of oxygen gives 0.5 moles of water, which then works out as being 9 grams of water.